Hi there, welcome to the RPS project. I'm Richard and today I'm going to have a look at the PNP bipolar junction transistor. Simple thing supposedly. I've read that it's just the opposite of the NPN bipolar junction transistor. Can it be that simple? Don't know. Well, I've got it here on the bench, so I'm going to do a few tests and see what it does and see how it turns on and if I can understand it. So let's get on with it and have a look at it. Okay, so I've got this PNP transistor set up on the workbench here. It's on this breadboard here. Can't quite see it. It's a bit out of shot. I want to try and get the meters and the scope in shot more than the transistor. But it's a basic circuit. It's a very basic circuit on here. It's exactly what you get for a Class A amplifier biasing. Only I've got a PNP transistor rather than the NPN. We'll actually have a look at that afterwards, because the one thing I'd heard about was that the PNP is exactly the opposite of the NPN, so I might have a look and see how that reacts after I've had a look at the PNP transistor and see what it's giving me in the way of readings. Now I've got 5 volts on the power supply over here, a couple of meters. Now the way I've done this is that I've got this multimeter is reading, let's see where all the leads are going, this is like spaghetti junction around here. That is reading across, where's the negative, across the emitter resistor R1. That's the resistor between positive voltage and the emitter. Then I've got transistor, and then on the collector side I've then got a blue diode, just had a shot here I think. I've got a yeah, everything's falling apart. I've got a blue diode over here. I've got resistor, then the blue diode down to 0 ground, 0 volts, whatever you want to call it. And I've got this multimeter is reading the voltage across that point. It's got the voltage there at the collector, so effectively really I'm reading the voltage in the same place twice, because I've also on the scope I've got one scope on the base, which is input number 1, channel 1, which is red, and channel 2 is reading the collector. So I'm going to see what the collector voltage is as it changes, as I change the base. Now this is an PNP transistor, so from what I've read the base has to be lower than the emitter for it to turn on. So let's turn this on anyway. 5 volts, and there we go. We've got up here 5 volts on the base. So the collector's 0 and the voltage across R1 is also 0. So if I now turn down the base voltage, it should turn on the emitter base junction, and there we go, it turns on. It's suddenly on. It seems to be very twitchy, this. Suddenly it's gone from nothing to being on. And if you look at that, the base voltage has dropped about 0.7 of a volt, because this is in 1 volt divisions on there. So from this point 1, 2, 3, 4, 5, and then come down, it's about 0.7, and this has jumped up to about 2.5, which is what I've got there. But obviously across the emitter resistor I've got nothing still, so it's literally only just on. So if I turn the base down more, I should be turning the transistor on more, and it is. Turn it down to the point where the base and collector are at the same voltage. So the voltage across the emitter is 0.85 around about. I've got 3, get that up a bit more, didn't sit very well, the bracket's gone a bit. Never mind. So I've got 3.5 volts at the collector, which is right, isn't it? I mean, 1, 2, 3, about 3.5 volts there. That's what I've got across this diode. Sorry, not diode, the LED. It is diode, just lights up. And that seems to work fine, but at what point does that become saturation? And as I turn the base down more, I should reach a point where the voltage across the LED and the voltage across R1, which is to the emitter, equals my supply voltage, which is actually 5 volts. And it's about there, really. Bit fiddly. So I've got, yeah, at this point we've got the transistor moving into saturation. So if I turn the base voltage down even more, then the collector and emitter are effectively at the same voltage. I suppose if I was just to take the base, this off the base, this probe, connect onto the, there you go. So the collector and emitter are at the same point now. So if I was to increase the base voltage, even though we're not seeing the base voltage, I am turning it down. You just can't see it. I've not got a probe on that base. But the collector and emitter will move together because the transistor is fully turned on. So it's not there, it is there, and it's fully turned on. We're just moving the point at which voltage, where the voltage is. I'm getting more voltage across the emitter resistor and less voltage across the LED. But the basics of that are that we have the transistor in saturation. So we're just moving the bias point between, because effectively it's just like a I was going to say resistor bridge, but I've forgotten the word for it. You know, we just two resistors in series, and we're just looking at the center point really, and all we're doing with the transistor by changing the base voltage is moving that biasing point until there's a point where the transistor is not fully turned on, which is there, and we're no longer just moving that bias point. Fully saturated. Let me just put this back on the base, the probe. So we've got the base and the collector, and then change this. As you see, again they change at the same rate. As I decrease or increase the base, and they reach a point where they cross over, there you go, and it turns off. So that seems to be fairly straightforward. As I turn it on, the transistor turns on, the LED will come on, I will get more voltage across my LED, which keeps increasing. I'll get more voltage across the R1, which is basically a sort of put-up resistor for the emitter, and then at some point the base and the emitter voltage are the same, but as the base goes lower, I reach a point where the emitter is high, is at a point where the collector and emitter voltages across the respective diode, LED or whatever, then equals 5 volts, and the transistor's fully turned on, and as I increase or decrease the base, the emitter will follow it, and the collector will follow that voltage, because I'm just turning on the transistor harder and harder. And that actually makes sense to me now, because I'd always struggled a bit with the PNP transistors, because when I looked at it, it's always like saying there's a negative voltage to the collector. There's a negative voltage to the collector, which I've got here, which is on there, but effectively, or the emitter, it depends which way. I suppose that's the other thing. These transistors can be turned round. We just have a conventional way of always putting them. But yeah, so as the base voltage comes down and turns on this transistor, the emitter voltage will go up, as it does there, and also the collector voltage will go up. But at some point, when the transistor is fully turned on, they now follow each other because it's just fully on, so it doesn't. There's no difference between the two. That makes sense to me. It's not, doesn't have to be a negative voltage. It's just that the base has to be minus to the emitter, which makes sense now because you can see it turn on. So is this exactly the same as an NPN transistor but in reverse? So I think what I'm going to do is I'm going to quickly swap this circuit round and put in NPN and see if that is effectively the same but opposite. And remember, in this scenario, as I turn the base down, transistor turns on, the collector and the emitter voltages across R1 and the LED go up until they reach saturation, and then the voltage, the bias point across those two will change, so you get more voltage across R1 and less voltage across the LED from the collector. So yeah, works fine. I think I get that now. So I'm just going to set up the other circuit and we'll have a look at that. Okay, so I popped the NPN transistor in. I'm just going to look to see if what I get on the scope and the readings I get are basically the same but the opposite of the PNP that I'm trying to understand. So let's turn this on, and well, yeah, we've got, this is my baseline. I set my baseline here, and up here we've got about the voltage at the collector is about 4.5 volts. Now I've noticed here that, as you can see, on the voltage across this LED is about half a volt, so 4.5 and 0.5 a volt. So yeah, that equals, and what it's done is it's raised this base voltage up slightly. I think this is just because of the way I biased this transistor. I put a resistor on the emitter, and I've got a resistor, two resistors in series, so I've got a on the base, so that's always going to raise the base voltage up slightly, but it is lower than the point where the transistor will turn on, and that's what I wanted, so I can actually see the point where the transistor turns on and start to see the effect of the base emitter junction turning on. So let's turn this pot and get the base voltage to increase this time rather than decreasing. And yeah, a bit twitchy, but yeah, it's about 0.7 of a volt. This base turns on the transistor. For that, it's sort of, then there you go, it's turned on. So now the collector voltage is dropping, but we're getting more voltage across the LED, and the voltage at the emitter is increasing. And as I turn the base voltage up, I turn the transistor on more, so there's less and less resistance between the collector and the emitter, and at some point I will get a point where the voltage across the LED and the voltage across the emitter resistor equals 5 volts, which is about there actually, somewhere on that. Is it, were we on about that? Yeah, I got 1.55 there, 3.38, yes, there's some variance because all these cables, it's like Spaghetti Junction around here. And if anybody doesn't know where Spaghetti Junction is, it's in the UK, it's near Birmingham, and it's a rather nasty roadway contraflow system on the motorway that's just like spaghetti. I don't like driving on it, it's a pain in the backside. Anyway, So now I'm at a point where supposedly if I turn the base up, the collector will start to follow it, and it does, because the transistor is in saturation, and it's just going to follow that base voltage as I turn the base emitter junction on harder and harder. And of course the thing about that is, as the emitter voltage goes up, the collector voltage has to come down. It can't stay the same because there's only 5 volts, so it's going to just be equal to 5 volts. Like the resistor divider, isn't it? You know, you've got the middle point, the bias point in the middle, so I'm just changing that bias point now, really, when it's in saturation. But as I go past that and I'm turn the base down, we're not in saturation until I turn the transistor off. So yeah, it is confirmed from what I've seen now, with having these 2 meters and the scope, that's really helpful. The PNP transistor is basically just the opposite of the NPN transistor. You just have to remember that you've got to have a voltage on the PNP, the base voltage has to be lower than the emitter for that junction to be turned on successfully. And on the NPN, the base voltage has to be higher than the emitter voltage for the transistor to be turned on successfully. And as you go into saturation, obviously the collector and emitter voltage will follow each other, because there's no resistance in the transistor anymore because it's fully turned on in saturation. Yeah, I get that now. I had trouble with this before, but that seems actually quite sensible now. I think I get it. So there you have it. The PNP bipolar junction transistor, very similar to the NPN, but obviously works with a negative voltage, well, at least not negative, but minus voltage to the supply voltage on the collector or the emitter. It seems to work either way. I'm not quite sure how I would use it in a circuit. I know it's used quite a bit in audio circuits, I see it quite often, but I'll have to do some more investigation to understand quite how it reacts or is reacting within that circuit. So yeah, more experiments to come, a bit more testing, more things to do with it. Anyway, if you didn't like this video, you know what to do. If you did, give me a thumbs up, subscribe, and all comments are welcome. I'd love comments on this little PNP transistor, because my knowledge is quite limited on using this particular one, and I'd like to know a lot more. So if you've got some comment to tell me about how you think it should be used, then please do so. Anyway, catch you next time.